Hello everybody to our next GeoBoost video in the Submodule 1.5 combination of ground source heat pump systems with other renewables, integration of ground source heat pumps in low temperature grids, and also integration of ground source heat pumps into spatial energy planning. And this is what we want to talk about today. So why do we need spatial energy planning? Spatial energy planning is actually the base for municipalities and cities to have a plan for the heat transformation. This is very important to know. And so you need several steps to conduct that. First of all, you have to assess a heat demand. So this is how much heat the people need to heat up their houses. So you need that for every single household and every single building in the city. And then you have to assess also what is the actual state of energy supply. So what use the people for heating their houses. And at the moment, it is a lot fossil-based heating, unfortunately. So to make this change to renewables, you have to assess also the potential of the renewable sources. In this case, also the potential of shallow geothermal. What do you have available here in the area of interest? So on the left side, you see an example of the city of Munich, and all the green and blue colors here are favorable areas for shallow geothermal, in that case of groundwater heat pumps. So by these potential analyses, you identify potential priority areas. Which areas are very favorable for specific renewable sources and for shallow geothermal in this case. And if you have done that and you overlay everything, what is the heat demand and what is the potential, then you can define measures and implementation activities. So measures can be, for example, that the city decides to go with energy consultants in specific quarters and talk to the people and say you have a huge potential for shallow geothermal, for example. So how can we encourage you to exchange your heat supply? And of course, some other measures can be that the city decides to set up some incentives also for the encouragement of the general public. And after a while, you have to monitor how good is this transformation process and so on. So you have to update your spatial energy planning every few years, every 5 years, something like that. Of course, going more in detail, we have to talk about what is a potential. So there are several potential definitions, and we have to talk about, okay, which potential do we really assess? So there's the natural potential, technical potential, ecological, economical, and social potential, and we have a viable potential. So actually, all these potentials play a role. Normally, you have a theoretical potential, but you can just use a part of it because it's not technical. There's no technical possibility to use all of these potentials, so you limit the natural potential by that what you can really technically produce. And then, of course, if you have some ecological aspects like it must be in line with all environmental aspects and regulations, so you cannot set up shallow geothermal, for example, everywhere. So if you have a water protection area, it is mostly not allowed to use here shallow geothermal, so the potential is again reduced a little bit. Also, if you see there's a economically feasibility, so is it economically possible to set up or logical to set up here a renewable system? So if it's too expensive, of course, it makes no sense. So it limits the potential again. And then also social acceptance. So if it's not acceptable to build here whatever shallow geothermal, but this is very unlikely, but then it reduces the potential again. So then what you really assess is a part of these technical and natural potential, and we call it viable potential, just to define that here. How we do it. So, for example, for open loop systems, I will just give you one example here. We have to integrate all conditions, frameworks, and limitations in the potential analysis because we want to assess a potential which is really viable. So what you can really then implement at the end. So for example, here we have a technical potential on the left side and we have some constraints. So we do not have a thermal recycling. It's maximum allowed to draw down of 1/3 thickness, and also the well distance must be minimum 10 meters. So this actually is a constraints for this potential. And on the other side, some natural conditions like the hydraulic parameters. What is the aquifer thickness? Do you have groundwater? If you have just a very small amount of groundwater, of course, then you have not a high potential. So this is all what you have to integrate then to analyze and assess the potential that you have then an area where you can produce a lot of groundwater out of it, and then you have a high potential also to use it as an energy source. So we did that once in the example of Munich, and we also developed a methodology how we can quantify this potential, because that's quite very important that we quantify it, that we can compare it with other renewable potentials as well. So what we have here, we have assessed the groundwater thickness, we have assessed the temperature, the hydraulic conductivity, and also what is the distance to the surface that we can assess the potential. At the end, with the methodology which we developed, we assessed technical volume flow. So we assessed how many volume liter per second can we produce out of this aquifer. And you see a picture here. There's quite a lot in some areas. In some areas, it's a lot more limited because we have not so much groundwater there. So and then we can actually assess a potential, so a watt per square meter or whatever you have as a unit here. Can also have megawatt hours or whatever. And then you see this is what you can produce out of it here on a building level. Of course, you can assess also the potential of borehole heat exchangers. Here's one method. It's a G-pot method from Casasso and Seti. So here you see all parameters on the left side, what you have to use here. So temperature, the length of the boreholes, thermal conductivities, and so on to assess this potential. This is one example of an area in Italy where you see this is the thermal conductivity, and the thermal conductivity is one key parameter to assess here the potential for borehole heat exchanges. And then with these methodology and with these parameters, you can assess the potential, what you see here now in megawatt hour per year. And this is the potential for the specific area in Italy. Of course, as a summary, what you have to do for such a spatial energy planning and integrating the shallow geothermal potential, you have to do a lot of data acquisition and processing, status quo analysis of the heat demand, status quo analysis of the sources which are used at present, and then the potential assessment, what we explained before. You have to do a combination of all these and then overlaying, and then define the measurement and the monitoring development. And hopefully a lot of people decide to use then the shallow geothermal as a favorable heat source.